guess what? We're at 11.8. This is the last section of the book that we're going to be covering. It's time to celebrate, right? Well, before we do, let's talk about surface area of a sphere and volume of a sphere. Those are the last two items that we're going to be covering, at least at the textbook. We're still going to cover some things to get you ready for Algebra 2, so don't think that we're done just quite yet. So let's talk about that first term we see right here in our vocabulary. We talk about chord of a sphere, a segment whose endpoints are on the sphere. Right here. This is a sphere. Now, when they're talking about the endpoints on the sphere, it's not like we're going to draw a line on the outside. Okay? You take an object or whatever, and you're actually going to go through the sphere and then out towards the other side. It could be from like here to here on the outside, or way on the inside or bottom, wherever. And so that right there will be your chord of a sphere. It is going to be the endpoints, and it will be on the outer side. And it's not going to like you're trying to draw a line from here to here. That's a no-no. The next term we have is the great circle. It is the biggest circle in a sphere. It is in the middle, or what we could consider the equator. Take a look at our sphere again. Where would the biggest circle be, or the great circle? If I were to chop this right here, if I were to take something to chop this in half or slice it up, would it be right here? If I were to cut this through, would it be right here? Or, like we said, it would have to be right here in the middle. So if I were to split this, think about it, if I were to split this softball in half, right here in the middle would be the biggest circle. If I were to slice it down right here, the circle would be a lot smaller than it would be in the middle. And that right there is your great circle. We got two equations, two more to cover to get us through this lesson. The first one right here is the surface area of a sphere. It is S is equal to 4 pi r squared. All right, the surface area of a sphere, 4 times pi times r squared. And your last equation for geometry right here, we have volume of a sphere, and that's 4/3 pi r cubed. All right, so make sure, memorize them both and put those in your notes. All right, so let's go ahead and move on, and let's find the surface area of the solid, which happens to be a sphere right here. So we got ourselves, once again, surface area of a sphere is going to be 4 pi r squared. You could definitely see right here what our radius is. Hopefully, I'll circle it for you. It's 5. So you take yourself 4 pi. We got 5 squared. 5 squared is 25. 25 times 4, 100 pi. Okay. Remember, you are going to definitely see if you take the PSATs and SATs later, they're going to have problems where they have the answer in terms of pi. Okay, they're not going to have everything where they expect you to use a calculator. They expect you to actually, be able to do some of this in your head quickly to get the answer. All right, so we have 100 pi. Then if you were to go ahead and calculate that and put that in your calculator, you get yourself 314.16 centimeters squared. And that would be the approximate to the nearest hundredth. And I know that big ideas, and the book happens to have the answer in the nearest hundredth. All right. Let's take a look next up at number 3. Something different there. A few changes. Hopefully you noticed them. We start off. We have 2. Since they put it right in the middle, that means that it is the diameter. Remember, we need the radius. So we'll take the diameter, we'll split it in 2, and the radius is 1. All right, so there's part 1 right there. We figured out what the radius is. Let's go ahead now. Let's figure out our surface area. We got our equation. We got ourselves 4 pi r squared. And so we have 4 pi, radius is 1 squared. So this right here simplifies down to 4 pi. Great. We are done. Or are we? Remember, if you look at that diagram, how much of a sphere is that? Hopefully you realize that that right there is actually half of the sphere. So for our final answer, or to actually get our answer, we're going to need to divide this by 2, and this becomes 2 pi. Okay. Once again, why am I dividing my answer by 2? Because look at the diagram. That's not an entire sphere. It's only half of it, or what we call a hemisphere. And then so we'll divide it by 2, we'll get our answer, and then we'll round that to the nearest hundredth, and it looks like it becomes 6.28. And then we have ourselves feet squared. So now you are a pro at finding the surface area of a sphere. Let's clear that up. Let's go ahead and take a look at find the volume of a sphere. Start off, take a look at number 5. Remember, volume of a sphere we have is 4/3. And then we have ourselves pi r cubed. They give us 15 right here. That is the diameter. We need radius. We'll divide that by 2. So your radius is going to be 7.5. So let's start putting things together. We got 4/3 pi, and then you got 7.5 to the 3rd power. Okay, that's pretty much it. You can plug that in. You're probably going to need to put 4/3 in parentheses in your calculator if you're going to put everything in complete in one line. All right, so give yourself some time to calculate that out. You could always press pause, and then here's your answer. You should get 1,767.15. It's volume, so we need to put inches cubed, and there you go. All right, easy peasy. We're almost there. We're getting to that finish line. Let's drop down and take a look at number 9 next. It says, find the diameter of a sphere with surface area of 144 square centimeters, or 144 pi square centimeters. So they're saying we're dealing with surface area. So let's start off with the equation. Surface area is equal to 4 and then pi r squared. It looks like since they gave us the surface area right here, we're going to have to figure out what the radius is first. So we have right here 144 pi. We'll plug that in for surface area. And then we have 4 pi r squared. Let's get r by itself. I would start off, divide both sides by 4 pi. And nicely, that pi disappears. We just need to figure out, well, what's 144 divided by 4? So 144 divided by 4 happens to be a nice number, and that turns into 36 is equal to r squared. All right, so 36 is equal to r squared. We can go ahead and get r by itself. You got it. We got to square root both sides, and r is equal to 6. And that right there we would say is centimeters. We're not quite done because they say let's find the diameter, right? They're saying in this sphere, what we found was the radius, and we need to find the rest of it. and that would be adding another 6, or taking 6 and multiplying it by 2, and our actual answer diameter is equal to 12 centimeters. And there you go. Last one, number 10. It says find the volume of a sphere with a surface area of 256 pi squared inches. So let's see here. We got volume, which happens to be 4/3 pi r cubed. Okay, cool. But wait a second. They give us the surface area. How can I find surface area with volume? How does that tie hand in hand? Well, surface area is equal to 4 times pi r squared. What do they both share in these equations? They both have that radius. So we need to first figure out the surface area, or use the information with the surface area to find the radius, and then that could help us get to the volume. So let's go ahead. I'll start substituting things in. We have 256 pi is equal to 4 pi r squared. We'll divide both sides by 4 pi, just like what we did in the last problem. And guess what? Things start canceling out and working perfectly. And I guarantee you that was all done on purpose. So right here, where we take 256 divided by 4, that gets us right here 64. We square root both sides, right? And r is equal to 8. We found our radius. Great. What do I do with it? Plug it in to find the volume. So right here, our volume is equal to 4/3. We got pi. We'll take our radius, which is 8, and we will cube that. Last thing right here, plug it into your calculator, solve it all out, and volume is approximately 2,144 point. Looks like it should be 66 inches cubed. All right, and that right there is your volume. We have now finished our journey through geometry. Congratulations. I'll see you around when we start doing Algebra 2 stuff again.